Hey guys, Mr. Backerwork here. In this video we're going to look at grapher failure and hidden behavior. So in this first example we're going to look at the graph of the equation y equals 3 minus 1 over the square root of x squared minus 1. And the reason we're going to look at this graph is to see something called grapher failure. So if I pull up my calculator and I hit my y equals button, I already went through and typed in my equation. So you can go ahead and do that. When you're done, hit your graph button. And then what we're going to do is adjust the window a little bit. So I'm going to hit zoom, and I'm going to pick option number 4, z decimal. So we get this picture of our graph. Now, as we look at this graph, does it look like it has any x-intercepts? And what we should be noticing is that our lines are kind of stopping in the middle here. So it doesn't look like our graph has any x-intercepts. But we're actually going to go through and algebraically prove that our graph does have x-intercepts. So this is where we're getting something called grapher failure. There are x-intercepts to this graph. The picture on our calculator just isn't showing them. So to find the x-intercepts, what we're going to do is take this equation and set it equal to 0. So I'm going to plug in 0 for my y value. Now what I'm going to do next is take this fraction, and since it's a negative, we're going to have to add it over to the other side. And now for my next step, what I'm going to do is take the reciprocal of each side, meaning that I'm going to take the fractions and flip them over. The 3 doesn't look like a fraction, but it's 3 over 1. So if I flip that fraction over on the right-hand side, it ends up being 1/3. Doing the reciprocal of the left-hand side, we'll end up with that square root on top and the 1 on bottom, but divided by 1 doesn't really need to be in there, so that just leaves us with the square root of x squared minus 1. Now in order to get rid of that square root on here, we're going to have to square both sides. So we're going to get x squared minus 1 is equal to, now when we square a fraction, we square the top and the bottom, so we're going to get 1/9. Now we're going to take that 1 and we're going to add it over to the other side. So x squared is equal to 1/9 plus 1. Now if we're going to add 1 to 1/9, we're going to get common denominators. So 1 is really like 1 over 1, which is the same as 9 over 9. So we end up getting x squared equals 10 over 9. And then we're going to have to square root both sides to get rid of the squared on our x. So we're going to get x equals, anytime we square root something, we have to remember to put the plus and the minus in there. And then I'm going to go ahead and get a decimal approximation of this square root of 10/9. So when we type that into our calculator, we should get about 1.054. So this is telling me that our graph should have x-intercepts at just a little bit more than +1 and just a little bit less than -1. But our graph wasn't able to show that on our picture. So that's an example of grapher failure. There are x-intercepts, it just didn't show it in the picture. Okay, so this is why it's important to be able to solve an equation multiple different ways. If all you do is ever try to solve an equation graphically, you might miss out on some solutions. In this example, we're going to look at missing out on some hidden behavior. So we're going to look at the equation x cubed minus 1.1x squared minus 65.4x plus 229.5 equals 0. And we're going to go ahead and solve that one graphically. So I'm going to fire up my calculator. I already have my equation typed in, so you can go ahead and do that. When you're finished, hit graph. Now, if we are looking at a normal 10 by 10 window, notice that we can't see what's happening up here on this part of our graph. Our graph goes off the screen and then it comes back down. So that's an example of hidden behavior. We can't see something happening. So we need to make this window taller. So I'm going to hit my window button. To make it taller, I'm going to go down to my Y maximum, and I'm going to jump that all the way up to 500. So then I'm going to hit graph again. So now we can see that we get this nice view of our cubic equation here. We were looking for where this equation was equal to 0. So I'm going to hit second trace, and we're looking for the zeros. Those are the x-intercepts. So option number 2, I'm going to start on the far left-hand side. It asks me for a left-bound point, so I'm going to go over here, arrow left a couple of times from my x-intercept, arrow right a couple of times from my x-intercept. So we can find that first x-intercept at -9. Now, if we look at finding another x-intercept, if we hit second calc and pick option number 2 again, it looks like we've got another x-intercept happening over here around 5. So I'm going to arrow over close to that one. Left-bound point means we need to be left a little bit, so hit enter. And then right-bound means we need to be to the right, hit enter and enter. And it's saying that we should have another 0 at 5.1. But since this is a cubic equation, there's a chance that there might be a third x-intercept. But right now we're only coming up with 2 of them. Now I actually want to look a little bit closer at what's happening around this 5. I'm going to change my window. For my x minimum, I'm going to put 4.95. For my x maximum, I'm going to put 5.15. And then for my y minimum, I'm going to make it -0.1. And for my y maximum, I'm going to make it +0.1. And now if we graph that out, we can see that around 5, our graph is actually dipping below the x-axis. So there's 2 x-intercepts happening in here. So we were missing out on one of those by not having an appropriate view of our graph. So now we should be able to find both of the x-intercepts around here. So if we went second calc and picked the 0 option, so number 2 in here, we should be able to find this one on the left by doing our left bound and our right bound point. So that one is at 5, 0. And then if we do the same thing but over by our other x-intercept, so left bound I need to be on the left hand side, hit enter. Right bound I need to be on the right hand side, hit enter, enter. And then we get 5.1 and 0. So this equation does in fact have 3 x-intercepts. One of those x-intercepts was at -9. Another one of those x-intercepts was at 5. And our last x-intercept was at 5.1. So again, as you're looking at a graph, you need to be careful about grapher failure, and you also need to be careful about hidden behavior happening within your graph. That's going to be it for this video. Thanks for watching.